The first specific preference that we consider is Cobb Douglas preferences. Cobb Douglas preferences. Consider the indifference curves represented by u1, u2, u3, etc. y, x. X. This is the familiar shape of indifference curves satisfying all the axioms: completeness, transitivity, non-satiation, and convexity. A utility function which generates such an indifference curve is written as uxy is equal to x raised to alpha y raised to beta. A utility function which generates such an indifference curve is denoted as x raised to alpha y raised to beta, and alpha and beta positive constants, each less than 1. Remember this. This is a general shape of a specific type of utility function we have discussed earlier. U is equal to root xy, that is x raised to 0.5, y raised to 0.5. This was a special case where alpha is 0.5, beta is also 0.5. This is the general case, and we have shown that this utility function generates indifference curves having this shape. Now, this equation is the more general case, and it is known as the Cobb Douglas utility function. This equation is known as the Cobb Douglas utility function. The name is derived from two researchers who used such a function in the context of production relations in the US economy, and that we will see in detail. The Cobb Douglas production function used it to study production function. So the name, as the functional form is same, it is known as Cobb Douglas utility function. Now, the size of alpha and beta determines the relative importance of two commodities to the consumer. The relative importance of x and y to the consumer. Now, this is a highly useful utility function, and this has wide applications in the context of the theory of consumer behavior. And the Cobb Douglas indifference curves look just like the nice convex monotonic indifference curves that we refer to as well-behaved indifference curves. That is, the indifference curves generated by Cobb Douglas utility function is the well-behaved indifference curve satisfying all the four axioms. Actually, this is the case of imperfect substitutes. The case of imperfect substitutes. This is the case of imperfect substitutes. Such a utility function satisfies all the four axioms of consumer preferences. So the indifference curve generated by such a utility function is well-behaved indifference curves. Now, a monotonic transformation of the Cobb Douglas utility function represents exactly the same preferences. Remember this. when we specify preferences in utility terms, we use the concept of ordinal utility. What is required is the ordering. What is important is the ordering. The magnitudes are not important. So monotonic transformation is order preserving. Order preserving, as we have discussed earlier. So if a monotonic transformation is given, as it is order preserving, it represents exactly the same preferences. That is, as we have seen, u x1 y1, so x1 y1, a combination is if it is preferred to combination x2 y2, if and only if u of x1 y1 is greater than u of x2 y2. Since utilities are defined only in ordinal terms, we can represent the preferences by this utility function or a monotonic transformation of this utility function, because monotonic transformation is order preserving. Order preserving. Monotonic transformation is order preserving. Now let us consider monotonic transformations of the Cobb Douglas utility function which are order preserving. Suppose that we take the log v of xy as equal to ln of x raised to alpha y raised to beta is equal to alpha ln x plus beta ln y. Alpha ln x plus beta ln y. Now, if you draw the indifference curve for this utility function, this also just look like these indifference curves, because logarithm is a monotonic transformation. Logarithm is a monotonic transformation. So if utility function is vxy, that is the log of the original utility function, the indifference curve will be having the same shape, because log transformation is monotonic transformation. Now we consider another case. uxy is equal to x raised to alpha y raised to beta, and suppose that we raise the utility to 1 by alpha plus beta. Suppose that we raise utility to 1 by alpha plus beta, so that we have uxy as equal to x raised to alpha by alpha plus beta, y raised to beta by alpha plus beta. Utility is raised to the power 1 by alpha plus beta, so that it is equal to x raised to alpha by alpha plus beta, y raised to beta by alpha plus beta. Now we define delta as equal to alpha by alpha plus beta and 1 minus delta as equal to beta by alpha plus beta. Beta by alpha plus beta. So that we can write uxy as equal to x raised to delta y raised to 1 minus delta. 1 minus delta. We write uxy as equal to x raised to delta y raised to 1 minus delta. Delta plus 1 minus delta is equal to 1. Delta plus 1 minus delta is equal to 1. Now, it means that we can take a monotonic transformation of the Cobb Douglas utility function that make the exponent, the sum of the exponents equal to 1. This is another monotonic transformation. with the uxy is equal to x raised to delta, y raised to 1 minus delta, and the indifference curve generated by this will also be this shaped. So, the Cobb Douglas with the alpha is equal to 0.9, beta is equal to 0.3, behave just like the Cobb Douglas utility function with the delta is equal to 0.75, 1 minus delta is equal to 0.25, because this is also order preserving monotonic transformation. So, this is the Cobb Douglas utility function and indifference curves associated with the Cobb Douglas utility function. And remember this, in the case of Cobb Douglas utility function, the indifference curve is well behaved. The indifference curve or the preferences, as the preferences, because this indifference curve in terms of preferences satisfy all the 4 axioms. So, this is the standard shape of the indifference curve, satisfying all the 4 axioms. So, is known as well behaved indifference curves. Well behaved indifference curves. This is the most familiar shape, negatively sloped, convex, satisfying all the 4 axioms. That is it.